Hello everyone. In this video, we will discuss about Huckel rule and aromaticity, and we will also discuss what are the necessary conditions required for a compound to be aromatic, anti-aromatic or non-aromatic in nature. And before going to discuss these terms, let us discuss what are the learning outcomes of the present video. After completion of this video, you shall be able to explain Huckel rule, learn about the aromaticity of the organic compounds, understand the difference between aromatic, non-aromatic and anti-aromatic compounds. You shall be understand aromaticity in benzenoid and non-benzenoid ring systems, and you will also learn about some special cases. What do you understand by term aromaticity? As we know that the term aromatic was given to those compounds which are having characteristic odor or aroma which is similar to benzene-like compound. But nowadays, chemists have shown completely different method of deciding whether a particular compound can be of aromatic or non-aromatic or it can be of anti-aromatic of type. But for a compound to become a aromatic, anti-aromatic or non-aromatic, it must be satisfy certain conditions so that we can say that the given particular compound can be of aromatic, anti-aromatic or non-aromatic. The aromatic compounds they also contains continuous conjugation of pi electrons, as we can say in benzene. In benzening, it is cyclic in nature, and this is also having alternate double bonds and single bonds which are present in conjugation. Due to this conjugation, continuous conjugation, that ring is having continuous pi electron above and below the cyclic ring so that it will get stabilized due to the high resonance energy. And instead of giving addition reaction similar to alkenes or alkynes, these benzene type compounds which resembles with the benzene, yeah we can say benzene, they undergo substitution reaction instead of giving the addition reaction. Now let us discuss about the term aromaticity. We can say that the property of exhibiting aromatic character is termed as aromaticity. Yeah, aromaticity in fact a property of sp2 hybridized planar rings in which the p orbitals one is present on the corners of this ring allows cyclic delocalization of pi electron that is called as aromaticity. Now let us discuss the criteria for aromaticity. In order to a compound that it must be aromatic in nature, it should follow the following important condition, and one of the important condition that it should be cyclic in nature. As we can see in the below examples that all compounds are cyclic in nature. Let us take example of benzene. In benzene, all the corners they represent the carbon atom which are joined by each other forming a cyclic ring. Similarly, if we are taking the other compound, like we are taking the example of pyrrole, in case of pyrrole, each corner, these four corners, they represents the carbon atom, while this nitrogen it also involved in the formation of cyclic ring, that is the five-membered ring. Similarly, in case of furan, that is also forming five-membered ring including oxygen atom, and in case of thiophene also that is also having a five-member ring which includes also sulfur in the formation of cyclic ring. Second important condition for a compound to become an aromatic that it should be planar in nature. Yani it means that it should have pi electron cloud which should be in conjugation above and below the cyclic ring without any interruption in that one. That means it should be in properly in conjugation. There should not be the any interruption in the pi electron cloud which is located above and below the cyclic rings in all the cases. And one of the most important conditions for a compound to become aromatic that it must follow the Huckel rule. Yani it should have at least 4 n plus 2 pi electrons in the cyclic ring present. As we can see in case of benzene, we have 3 pi bonds. It means we have 3 pi bonds. It means they are equal to the 6 electrons. Similarly, in case of nitrogen, we have 2 double bonds. That means equal to 4 electrons. But 2 electrons will be given by the nitrogen. That also considered in case of delocalization. That's why that will also follow the 4 and plus 2 pi electrons. Similarly, in case of furan also and thiophene also. Then we can say that aromatic character is not only limited to the benzene type of structure. Yeah, we can say only those compounds which are having 6 carbon atoms which are joining with each other. That can be also possible in case of those compounds which are having 5 member ring. Yeah, we can say other than the carbon atoms, they also contain some other atoms like nitrogen, oxygen, sulfur, including in the ring to form the cyclic ring. So that compound can also be of aromatic nature and they can also follow the Huckel rule to become aromatic in nature. Now let us discuss Huckel rule. The aromatic character of cyclic compounds can be explained in terms of Huckel rule, and according to this rule, the cyclic pi molecular orbital, yeah, we can say electron cloud, it can be formed by the overlap of p orbital that must contain 4n plus 2 pi electrons, where n is equal to integer value. That means it should have 0, 1, 2, 3, and so on, etc. value. This is referred to as Huckel rule. And we can also say that cyclic compounds, they should contain number of electrons per electron that should be equal to 2, 6, 10, 14, 18, 2 per electrons within the cyclic ring. These types of compounds, they must follow the Huckel rules. Yeah, we can also define Huckel rule in terms of another way that all the aromatic compounds, they must contain odd number of electron pairs. As we can say in case of benzene, we can say that benzene we have 3 double bond. 3 double bond means 1 pi bond equal to 2 electron. That means it is having 6 pi electron in case of this cyclic ring. Yeah, we can say that it is equal to the pi 1 electron, that is 3 electron pairs it is having in case of benzene. That is equal to the odd number. If we are taking the pi electron, that number should be equal to the 2, 6, 10, 14, 18, 22 pi electrons. But if we are considering in case of electron pair, that number must be odd. As we can say that in case of benzene, we have 3 electron pairs, one in each pi bond. Similarly, in case of pyrrole, they also contains the 6 electrons in case of cyclic ring. That's why they are also aromatic in nature, because in case of 2 pi bonds, as we can see in structure of pyrrole, it is having 2 pi bond that have 4 pi electrons which is in present ring. Along with this 4 pi electron which is from the two double bond, nitrogen also consists of lone pair electrons that also includes in the formation of pi electron cloud above and below the ring of pyrrole. That's why this also follow the Huckel rule. Similarly, furan and thiophene ring structures can also follow the Huckel rule. Now let us discuss various terms of aromaticity. Whether compound will be of aromatic, or it will be of anti-aromatic, or it will be of non-aromatic. There are some conditions that must be fulfilled by the compound so that they can become aromatic, anti-aromatic, or non-aromatic in nature. First, let us take aromatic in nature. Those compounds can be of aromatic in nature that must follow the certain condition. First important condition for a compound to become aromatic that it should be cyclic in nature. Second, one of the important condition for this compound that all the atoms present in the ring, they must be sp2 hybridized atom. Yeah, we can say sp hybridized instead of sp3 hybridized atom. And they should also having planar structure. Yeah, we can say they should be in the flat type of structures. And one of the most important conditions for a aromatic compound that they should follow the Huckel rule. That means 4n plus 2 pi electrons should be followed by the compound to become aromatic, and they must have electrons, that is pi electron, in number 2, 6, 10, 14, 18, 22 in case of cyclic ring. So those compounds that follows the all these conditions, they must be aromatic in nature as in case of benzene या other compound. Similarly, if we are discussing about the anti-aromatic term, those compounds with these three conditions which are also satisfied by the aromatic compound, that must also be satisfied by the compound which are anti-aromatic in nature. Yani that means they should be cyclic in nature. They should also having sp2 hybridized atoms in the cyclic ring. They should also having planar in nature. But instead of following the 4n plus 2 pi electron, that means having 2, 6, 10, 14, 18, 22 pi electron, they must follow the 4n pi electron rule, in which they are having 4, 8, 12, 16, 20 pi electrons within the cyclic ring. That must be multiple of the 4n. We can say that these will follow the 4n pi electron rule. That means when all these conditions will be satisfied by a compound, that must be of anti-aromatic type of compound. Similarly, if we are taking the example of non-aromatic compound, then all the conditions that must not be satisfied by the compound, that means it should not be cyclic, that is, it is non-cyclic in nature, it should not possess sp2 hybridized, but instead of that one, they should have sp3 hybridized atom, and they should all also having non-planar structure. When they are satisfying these conditions, these type of compounds are referred to as non-aromatic in nature. Now discuss aromatic character of some cyclic compound. Now let us take example of monocyclic system. Now what is monocyclic system? Monocyclic systems are those systems in which atoms are combining with each other to form a closed cyclic ring, as we can see in case of benzene. Similarly, if we are taking the example of heterocyclic compounds like we can say pyrrole, furan, thiophene, these are also referred to as monocyclic system, because in this case also four corners represents the four chiral atom, while fifth member of the ring, that in case of pyrrole it is nitrogen, in case of furan it is oxygen, in case of thiophene it is sulfur. All five members they are joining with each other to form a closed cyclic ring. That's why they are also referred to as monocyclic system. We can say that all the monocyclic systems shown here in this case, they must follow the Huckel rule condition. What is the Huckel rule condition? That they must be having 4n plus 2 5 electron system in case of cyclic system. As we are taking example of benzene, we can see that in case of benzene, they are having 3 pi bond. 3 pi bond means they are having 6 pi electrons. When we are applying this in case of 4n plus 2 pi rule, we can see that 4n plus 2 is equal to 6 and 4n is equal to 4. That means n will be equal to 1. So that's why its value is coming in the integer value. That's why benzene will be aromatic in nature. Similarly, if we are having 6 electrons in case of pyrrole, furan, thiophene, they must also be aromatic in nature, because they are of type of heterocyclic type of system. That is also example of monocyclic. How it is possible that in case of and pyrrole, furan, thiophene, they have 6 number. As we can see that in case of pyrrole, we have two double bond. Two double bond means they are having 4 pi electrons from the two double bond, while remaining 2 electrons will come from the lone pair present on the nitrogen, oxygen, and the sulfur. In that case, they will also contribute in case of delocalization of the pi electron cloud that will be available above and below the ring present. That must be without interruption. That's why we can say that pyrrole, furan, thiophene, that must also be aromatic in nature. Now let us see example of cyclooctatetraene, whether this compound will be aromatic in nature, non-aromatic or anti-aromatic, that we can explain in this video. Now let us see example this one. This cyclooctatetraene, it is having 4 pi bonds. It means that will having 8 pi electrons in case of this cyclooctatetraene. But if when we are applying this in case of 4n plus 2 pi electron, then we will get that 4n equal to 6. We will get the fraction value. That means it will not follow the Huckel rule, because according to Huckel rule, the n value must be integer. It should be 0, 1, 2, 3. But in case of cyclooctatetraene, because we have 8 pi electrons in case of cyclooctatetraene, value is coming fraction, that is 1.5. So that must not be aromatic in nature. Now let us take whether it will be anti-aromatic or non-aromatic in nature. Now come to this one. If we are seeing that all the pi bonds present in case of cyclooctatetraene, they are present in conjugation. That means they are having single and double bond present in alternate position, or they must be planar in nature. They are cyclic in nature and they should also having planar in nature. But in actual structure of cyclooctatetraene, it is not planar in structure, but it is having similar to the tub shape structure. That's why this is not flat or planar type structure. That's why it must not follow the rule of Huckel rule. In case of, it appears that it should have 4n. 4n means 4, when we are applying this electron, that it should have 8 electron. That means it should be having anti-aromatic. But due to the tertiary structure, this compound is not anti-aromatic, but it is the non-aromatic type of structure due to the non-planarness in case of this compound. In case of previous slides, we have discussed the aromatic character of the monocyclic systems. Now, in the slides, we will discuss about the aromatic character of the fused ring system, because it is not necessary that it can be only possible in case of monocyclic system, but aromatic character can also be possible in case of fused ring system. Now, let us discuss what is fused ring system. If we are taking these examples, we can see that fused ring systems are those ring systems in which two or three rings are fused with each other, in which, as we get the example of naphthalene, here two carbon atoms are fused between the two benzene rings. That's why this is referred to as the fused ring system, in which we can see that we have five double bonds are present in case of naphthalene. It means that is having 10 pi electrons, that must follow the 4n plus 2 pi electron, because according to 4n plus pi electron, number of pi electrons should be 2, 6, 10, 14, 18, etc. Similarly, if we are taking the example of anthracene, which is the tricyclic system, also example of fusing system, where three benzene rings are, these are fused with each other. In case of this one, four carbon atoms are joining with between the two fused rings, that is example of anthracene. And in case of, we can see that here 7 pi bonds are present. 7 pi bond means we are having number of pi electrons in case of anthracene, that is equal to 14 pi electrons. That must also follow the Huckel rule, that is 4n plus pi 2, because according to 4n plus 2 pi electron rule, number of electrons should be equal to 2, 6, 10, 14, and so on. So that will also having aromatic character in case of fused ring systems. Now let us take some examples of compounds in which we can identify whether compound is aromatic, anti-aromatic, or non-aromatic type of category. Now first of all, we are taking the example of cyclopropyl. In first example, we have seen this is the cyclic ring, in which we can see that it is having only one pi bond, which means it is having two pi electrons in it. So it should follow the Huckel rule according to the 4n plus 2 pi electron. But because in this case there is no continuous pi electron cloud in case of cyclic ring, because in this case there is one sp3 hybridized orbital is also present. That's why this is interrupted the continuous pi electron cloud in case of cyclopropene. That's why this is not considered aromatic compound, but instead of aromatic, it is the example of non-aromatic because it is not having the continuous pi electron cloud. That's why due to that one it is not following the 4n plus 2 rule. That's why it is example of non-aromatic. Similarly, if we are taking the example of cyclopropenyl cation, in this case we can see that it is also having one pi bond, which means it is also having two electrons, and that is also follow the Huckel rule. That means 4n plus 2 is equal to, where we are getting the n is equal to 0. That means it is having integer value. But in this case, as we can see, there is a plus charge in the corner of cyclic ring. That's why due to this plus charge, delocalization of pi electrons can be possible in this ring. That's why this cyclopropenyl cation will be of aromatic in nature. As we can see in this case, how delocalization possible in case of cyclopropenyl cation. That's why it is aromatic in nature. Similarly, if we are taking the example of cyclopropenyl, in this case, we can see that we are having four electrons. Two pi electrons are coming from one pi bond, while two electrons are coming due to this negative charge. That's why instead of following 4n plus 2 rule, it will follow the 4n rule. Because it is following the 4n rule and is also cyclic in nature. That's why we can say that it is the example of anti-aromatic. But because anti-aromatic compounds are not stable as compared to the aromatic compound, that's why theoretically it is not stable compound. Now come to the another example for showing that whether compound is aromatic, anti-aromatic or non-aromatic. We will take the another example, that is cyclobutadiene. Yeah, we can say it is the 4-annuline. Now question arises that what are annulenes? Annulenes basically are those compounds which is mainly monocyclic in nature and in which single and double bonds are present in an alternate position, and the number of carbon atoms present in the ring, it will be represented in a bracket in case of annuline. That is, in case of cyclobutadiene, as we can see, there is made up of four number of carbon atoms, and so that's why we have written here 4 in brackets. So this represents the 4 annuline. So these are the annulenes. Now let us take the example of cyclobutadiene. In this case, we can see that it is of cyclic in nature and it also consists of two pi bonds. Two pi bonds mean it is having four pi electrons. So it should not follow the 4n plus 2 pi electron, but instead of following the 4n plus 2 rule, it is following the 4n rule, which is mainly utilized for the anti-aromatic compound. So as we can say, that's because we are having four pi electrons in this case due to the presence of two pi bond. So that's why these four pi electrons are the multiple of the four number. We can get value n is equal to 1. So that's why this cyclobutadiene is also cyclic in nature, planar, or it is also having, because its conjugation is in the alternate double bond, single bond. That's why pi electron cloud is in conjugation. That is, there is the uninterrupted pi electron present above and below the this cyclic ring in case of cyclobutadiene. So that's why this compound will be considered as a anti-aromatic compound. Similarly, if we are taking the example of cyclobutadienyl dication, in this case we can see that it is only one pi bond. That means it is having two pi electrons. When we will apply in this case, we will get the value n is equal to 0. It means it should follow the 4n plus 2 pi electron rule. Similarly, it is cyclic in nature and due to the presence of two plus charges at the two corners of the cyclobutadiene dication, in this case, delocalization of these two pi electrons can be possible over the ring, and it will form a continuous pi electron cloud above and below this cyclobutadiene dication. That's why, due to the cyclic in nature, planar in nature, and following the 4n plus 2 pi electron rule, that cyclobutadienyl dication is also considered in the category of aromatic compound. Now let us take another example of the compound to show the aromatic, anti-aromatic or non-aromatic character of the compound. We are taking another example, that is the cyclopentadiene. In this case, we can see that it is a cyclic structure, and due to the presence of two pi bonds, in this case, number of pi electrons present in case of cyclic ring, it is equal to 4 number. It means it is following the 4n rule according to the number of pi electrons which is mentioned according to the 4n rule. It means these 4 pi electrons, these are the multiples of the 4, so it should follow the 4n rule because it is also cyclic in nature, and so it should be anti-aromatic. But because we can see clearly that in this case there is no continuous conjugation is possible in this case, because in this case at this corner we are having sp3 hybridized orbital. So due to this sp3 hybridized orbital, it is not having continuous conjugation. Yeah, we can say pi electron cloud is present in case of this ring. So due to that one, there is a that do not have uninterrupted pi electron cloud in case of cyclopentadiene. That's why it is not anti-aromatic, but instead of anti-aromatic, this compound is referred to as non-aromatic because it do not have the uninterrupted pi electron cloud present in case of this one. Similarly, if we are taking the example, another example is a cyclopentadienyl cation. In this case, we can see that it is also having two pi bond, which means it is also possesses the four pi electrons. And when we are putting this, we can see that it is following the 4n pi electron rule, in which four pi electrons, they are the multiples of the four. That means, and it follow the anti-aromatic character. Similarly, here in case of at corner there is plus charge. So due to this plus charge, there is a continuation pi electron cloud is possible above and below the ring. So due to this continuation, yeah, we can say uninterrupted pi electron cloud present in case of cyclopentadienyl cation. This compound can be the example of anti-aromatic type compound. Similarly, if we are taking example of cyclopentadienyl anyl, in this case we are also can see there is also two pi bonds. That means they are also having four pi electrons in case of these two pi bonds. Similarly, that is also carrying a minus charge on this case. So two electrons are coming from due to this minus charge. That's why total number of electrons are equal to 6 electron. It is present in case of this cyclic system. So that follows the 4n plus 2 pi electron rule. That is equal to the Huckel rule. That means that compound is cyclic in nature because there is a continuous conjugation is possible with proper conjugation, and it is also having 6 electron. That's why this compound follows the Huckel rule, that is 4n plus 2 electron, or that means it is the aromatic type compound. Let us take some more example to show whether compounds are aromatic, anti-aromatic, and non-aromatic compounds. In this case, we have taken the example of benzene, that is equal to 6 annuline. As we have already discussed, what are anilines? Anilines are those compounds which are monocyclic in nature and in which double bond and single bond are present in alternate manner, and the number of atoms present in the ring that will be represented in case of bracket. So this is the example of 6 aniline that we are having benzene. Similarly, we will also discuss 7-member rings, that is cycloheptatriene. So first we are taking the example of benzene, whether it is aromatic, anti-aromatic, non-aromatic. So let me check. In this case, we can see that in benzene we are having 3 pi bond. 3 pi bond means they are having 6 pi electrons, plus it is also cyclic in nature. Continuation pi electron is also present above and below the ring. That is, there is uninterrupted pi electron cloud is present in case of benzene ring. So due to the cyclic in nature, planar in nature, uninterrupted pi electron cloud present in case of benzene ring, plus due to the following of 4n plus 2 rule, that is Huckel rule, this benzene ring is the aromatic in nature. As we can see that when we are putting the value in case of this 4n plus 2 rule, then we are getting the value n equal to 1, which is integer value. According to Huckel rule, when n value we are getting integer value, that will follow the 4n plus 2 rule. Similarly, if we are taking the another example, that is cycloheptatriene, in this case we are also having 6 pi electron due to the presence of 3 pi bond. But similarly, in case of this one, we are also having at corner sp3 hybridized orbital is present. So due to the presence of sp3 hybridized orbital, it cannot follow the 4n plus 2 rule because it is not planar in nature. So due to this non-planar in nature, this compound is also non-aromatic in nature. Similarly, if we are taking the example of cycloheptatriene cation, it is also having 6 pi electron, plus due to the presence of this electron at the corner, we will see that it is cyclic, conjugated planar, and also following the 4n plus 2 rule. So that's why due to the presence of cyclic, conjugated planar rule, it is also aromatic in nature. Let us take some more examples to identify whether compounds are aromatic, anti-aromatic, and non-aromatic type. First, take the example of cyclopentane. In this case, we can see that we are having only single pi bond. So, due to the presence of single pi bond, number of pi electrons present in case of cyclopentane, it will be equal to 2. When we are applying 4n plus 2 Huckel rule in this case, then we will find that it will follow the Huckel rule because number of pi electrons due to that one, it is having 2 pi electrons. So that must follow the Huckel rule because also it is having cyclic. So due to the presence of cyclic and following the Huckel rule, that is aromatic type in nature. Similarly, if you are taking an example of cyclopropanyl cation, which is also have three member ring, in this case we are also having single bond. So due to the presence of single pi bond, it is having number of pi electrons present. In this case, is equal to 2 pi electrons, and plus at the corner we are having plus charge. So due to that one, continuous delocalization of pi electron is possible in this case. So due to the presence of this continuous pi electron cloud, that compound must be aromatic in nature. Similarly, as we have discussed earlier, this is the example of thiophene. We have two pi bonds are present. Due to the presence of two pi bonds, number of pi electrons in this case are 4, plus 2 electrons are coming from the sulfur, which is also present in case of along with the parallel orbitals with the p orbital present at the corners of the carbon. So that's why total number of electrons are equal to 6. That is equal following the 4n plus 2 pi electron Huckel rule, plus also cyclic in nature, and continuous pi electron cloud is also present. Due to that one, that is also aromatic in nature.